Okay, here's the thing. Number 10, the death of absolute rest. For most of human history, motion seemed simple. You could be still, or you could be moving, and somewhere there had to be a true state of rest. Einstein removed that possibility completely. There is no universal frame where everything is at rest. Not on Earth, not in space, not anywhere in the universe. Every object moves relative to something else, always. You feel stationary right now, but you are rotating with Earth at about 1,600 kilometers per hour, orbiting the Sun at 30 kilometers per second, drifting through the Milky Way even faster. And none of those motions is more correct than the others. This is the principle of relativity. The laws of physics remain the same in every inertial frame. That means there is no hidden reference point, no cosmic center, no absolute stillness to compare against. Even light obeys this strange rule. No matter how fast you chase it, it always moves away from you at the same speed, 299,792 kilometers per second. This forces reality into something deeply counterintuitive. Velocities do not simply add. Time and space must adjust instead, and once they begin to adjust, nothing remains intuitive. The idea of being at rest is gone, permanently. This is not just a philosophical shift. It is irreversible. There is no experiment you can perform that will ever reveal a true state of rest. Reality has no preferred perspective, and that is where things start to break. Because if motion is relative, then time itself cannot be universal, and that changes everything. Number 9. When time stops agreeing, time feels steady, a constant flow, second after second, ticking forward the same for everyone. Einstein showed that this is an illusion. Time depends on motion. If you move fast enough, your clock slows down. This is time dilation. It is not a trick of perception, not a measurement error. It is real, and it has been tested. Atomic clocks flown on aircraft return slightly behind those on Earth. Satellites in orbit must correct for it constantly. Even your GPS depends on this effect. At 30 kilometers per second, Earth's motion around the Sun already shifts time, but the effect is small. Push closer to the speed of light, and everything changes. At 90% of light speed, time slows dramatically. Minutes for you. Hours for someone standing still. At 99.9%, days could pass outside, while you experience only moments, and this is irreversible. Once time has passed differently, it cannot be synchronized again. Two observers who separate at high speed will never fully agree on how much time has elapsed. Their realities diverge. This leads to a disturbing consequence. There is no single, universal now. Events that seem simultaneous to one observer may occur at completely different times for another. The flow of time fractures. Not metaphorically, physically. Time is no longer a shared backdrop. It becomes personal, dependent, flexible. And once time loses its universality, the structure of reality begins to loosen. Because if time can stretch, then events themselves can shift. And that leads to something even stranger. The order of reality can change. Number 8. The end of simultaneity. We assume events can share a single moment. Two lightning strikes, opposite sides of a train. They happen at the same time, or do they? Einstein showed that simultaneity is not absolute. It depends on where you are, and how fast you are moving. Imagine a long train moving at high speed. A flash of lightning strikes the front, another strikes the back. An observer standing on the ground sees both flashes at once. To them, the events are simultaneous. But inside the train, everything shifts. The observer in the middle is moving toward one flash, and away from the other. Light from the front reaches them first. Light from the back arrives later. So they conclude something different. One strike happened before the other. Both observers are correct. There is no contradiction. There is no hidden true timeline. This is not about delayed signals. Even after correcting for light travel time, the disagreement remains. Because simultaneity itself has broken, events no longer share a universal order, and once order becomes relative, causality begins to feel unstable. In extreme cases, observers can disagree on which event happened first. Cause and effect begin to blur. This introduces an irreversible fracture. You cannot reconstruct a single timeline that satisfies all observers. Reality no longer has a global sequence of events. only local ones. And that changes how the universe is stitched together. Because if simultaneity fails, then space and time cannot be separate. They must be part of something deeper, a single fabric, and that fabric can bend. Number 7. Space refuses to stay still. We imagine space as a stage, a fixed background, unmoving, silent. Objects move through it, but Einstein showed something far stranger. Space itself can change, it can stretch, it can contract. And it does. When an object moves at high speed, its length shrinks along the direction of motion. This is length contraction. It is not compression from pressure, not damage. It is geometry itself adjusting. From your perspective, a fast-moving spaceship appears shorter. From the astronaut's perspective, everything outside contracts instead. Both are correct. There is no fixed ruler, no universal measurement of distance. At 90% of light speed, the effect becomes noticeable. At 99.9%, distances collapse dramatically. A journey across the galaxy can shrink from tens of thousands of light years to something much smaller, but only for the traveler. And this change is irreversible in experience. Once distances have been traversed under contraction, there is no way to define a single true length afterward. Different observers carry different geometries. Space is no longer rigid. It becomes flexible, responsive, entangled with motion itself. And once space can deform, the idea of a straight path begins to fail. Because motion is no longer just about where you go. It is about how space reshapes around you. And that opens the door to something deeper. Not just changing space, but bending it. Number 6, gravity slows the universe. Gravity feels simple. Things fall. Objects attract. But Einstein saw something deeper. Gravity is not a force. It is the bending of space-time. Mass tells space-time how to curve, and that curvature tells everything else how to move. But the most disturbing part is not motion. It is time. Time slows down in stronger gravity. Near Earth, the effect is tiny, but measurable. Clocks on the ground tick slightly slower than those in orbit. Even a difference of a few meters changes time. Now push this further. Near a neutron star, gravity becomes extreme. Time begins to stretch. A second near the surface could equal minutes far away. Closer still, near a black hole, the effect becomes overwhelming. To a distant observer, an object falling in appears to slow and slow and slow, never quite crossing the edge. This is gravitational time dilation. From the falling object's perspective, everything seems normal. But outside, the universe accelerates, stars evolve, galaxies shift, time splits into incompatible flows, and this difference is irreversible. Once two clocks experience different gravitational fields, they will never fully agree again. There is no way to catch up on lost time. Gravity does not just shape motion, it sculpts duration itself. And if time can be stretched by gravity, then, in extreme conditions, it can nearly stop. Number 5. Mass and energy become the same story. Mass feels solid, permanent, a measure of how much stuff exists. But Einstein erased that boundary. Mass is not separate from energy, it is energy, locked in place. The relationship is simple and devastating. mc2 mc. A tiny amount of mass contains an enormous amount of energy because the speed of light squared is a colossal number. This is not theory, it is measurable. In nuclear reactions, small amounts of mass disappear. They do not vanish, they transform into energy explosively. In the sun, this process powers every photon you see. Hydrogen fuses into helium. A fraction of mass converts into radiant energy. Over billions of years. Steady, relentless, but under the wrong conditions. The same principle becomes catastrophic. In nuclear explosions, mass converts almost instantly, releasing energy on unimaginable scales. Cities erased, matter itself becomes light and heat. And once that conversion happens, it cannot be reversed. The original mass is gone, forever transformed. This is the irreversible core of the universe. Mass is not conserved in the way we once believed. It flows into energy, and energy can become mass again. Particles appearing from pure energy fields. Reality is not made of solid things. It is made of transformations. continuous exchanges between forms. Once that boundary dissolves, the distinction between object and process disappears. Everything becomes dynamic, everything becomes fluid, and that leads to an even stranger consequence. Even light can be bent. Number 4. Light no longer travels in straight reality. Light should move in straight lines. That is what geometry tells us. Shortest path, direct, unbending. But in Einstein's universe, straight lines do not always exist, because space itself is curved, and light follows that curvature. This is gravitational lensing. When light passes near a massive object, its path bends, not because it is pulled like a particle, but because space-time is warped, and light simply follows the shape, even though it has no mass. This effect is real. We have seen it. Galaxies acting like cosmic lenses, bending light from objects far behind them, creating arcs, rings, multiple images of the same galaxy. Sometimes magnified, sometimes distorted beyond recognition. On smaller scales, the same thing happens near stars. Light from distant objects curves around them, shifting their apparent position. Reality becomes a visual illusion. What you see is not where things are. It is where light was redirected, and this distortion is irreversible. Once light has been bent, its original path cannot be reconstructed perfectly. Information is stretched across space, smoothed, altered. In extreme cases, near black holes, light can orbit, looping around in circles before escaping, or never escaping at all. This breaks something fundamental, the idea that vision reveals truth. Because the universe is no longer optically honest, straight lines vanish, paths curve, and perception becomes unreliable. But this is still only geometry, a bending of paths. What happens next goes further. Because under extreme conditions, even geometry itself can collapse. Number 3. The clock at the edge of collapse. There is a boundary in the universe, a surface where time behaves strangely. This is the event horizon, the edge of a black hole. Cross it, and something irreversible happens. From far away, the story looks frozen. An object falling toward the horizon appears to slow. Its signals stretch, redder, weaker, until they fade completely. It never seems to cross. Time appears to stop. But this is only one perspective. For the falling observer, nothing dramatic happens at the boundary. No wall, no sudden force, just a quiet crossing. And then, there is no return. Inside, all paths lead inward, not metaphorically, physically. Space-time itself tilts. Every possible future points deeper into the black hole. The singularity is not a place you move toward. It is a moment you cannot avoid. Time no longer flows forward in the usual sense. It flows inward. And this process is irreversible. Once inside the horizon, no signal can escape. No information can be sent back. The outside universe loses access to what happens next, completely. This creates a deep fracture in reality. Information seems to vanish. History becomes incomplete. And physics begins to lose track of its own rules, because if information can disappear, then the universe is no longer predictable, not even in principle. This is where relativity begins to strain. And something more extreme is waiting. Because beyond this boundary, the structure of space-time itself starts to fail. Number 2. Falling into a broken geometry. Inside a black hole, space and time exchange roles. Not metaphorically, literally. Outside you can choose where to go. Left, right, forward. Time only moves one way, always forward. But cross the event horizon, and that structure collapses. The direction toward the center becomes unavoidable, like time itself. You cannot stop moving toward it. You cannot turn around. You cannot remain still. The singularity is no longer ahead in space. It is ahead in time. And just like the future, you cannot escape it. This is where geometry breaks intuition. Paths through space-time called geodesics twist inward. Every possible trajectory leads deeper. Even light follows this fate. There is no stable path outward, no orbit, no detour. Now the consequences escalate. As you fall, tidal forces grow. Differences in gravity stretch your body. Head and feet experience different accelerations. This process is called spaghettification. It is irreversible. Atoms pulled apart, molecules disrupted, structure lost. For a stellar mass black hole, this happens in seconds. For a supermassive one, you might survive longer, minutes, maybe hours, but the end is the same. Compression, destruction. All paths terminate. And yet, the deeper problem is not the violence. It is the mathematics. Because as you approach the singularity, the equations of relativity begin to diverge. Quantities grow without limit. Curvature becomes infinite. This is not just extreme, it is undefined. A place where the theory itself stops working. And if the geometry of spacetime can break, then the foundation of reality is no longer secure. Because beyond this point, we do not know what exists. Number 1. Where spacetime reaches its limit. At the very center of a black hole, there is no surface, no structure, no meaningful distance. Only a point, the singularity. Here, Einstein's equations collapse. Not gradually, completely. Curvature becomes infinite. Density becomes infinite. The fabric of space-time ends. This is not just extreme physics. It is the boundary of understanding. Every law we trust breaks down here. General relativity predicts this point, but it cannot describe it, because infinity is not a physical answer. It is a warning. Something is missing, something deeper. Now consider the consequences. All the mass that formed the black hole, compressed into something with no size, information carried by everything that fell in, seemingly lost, or encoded in ways we do not yet understand. This is the information paradox, a direct conflict between relativity and quantum mechanics, two pillars of physics, giving incompatible answers, and we cannot resolve it, not yet. Timescales here lose meaning. From the outside, black holes slowly evaporate through Hawking radiation over unimaginable durations. For a stellar black hole, up to 10671067 years. But what happens at the center during that time? We do not know. Because inside the singularity, time itself may not exist in any familiar form. This is the ultimate break, not just of intuition, but of theory. A place where reality stops being describable, where our equations fall silent, and where the universe keeps its deepest secret. For a brief moment in cosmic history, we exist where these laws still make sense. Between the birth of space-time and its most extreme edges, there is a narrow window of clarity, and within it, we are able to ask questions, to measure, to understand, however incomplete that understanding may be. Because beyond that window, reality continues, whether we can describe it or not.